Whether or not you're from the state of Michigan, you are probably at least familiar with the term lake effect snow. But how does it work? Michigan, being located in the middle of the largest freshwater lake system in the world, is obviously greatly affected by the lakes. First off, the lakes have a major moderating effect on Michigan's climate. This is thanks to the fact that water warms up and cools down slower than land. Temperatures in the waters of the lakes usually reach their maximum and minimum temperatures 4 to 6 weeks after air temperatures do. Within 20 kilometers of the waters, temperatures are as much as 11 degrees Celsius warmer during the winter, and these same areas can be 8 degrees Celsius cooler during the summer as compared to somewhere upwind of the lakes, like to the west over in Wisconsin, where winter temperatures are far colder and summer temperatures are much warmer. Typically, the lake effect is much stronger in the winter. On average, the temperatures over the lakes are much warmer than over the land. This is because the waters haven't frozen yet, so the surface over the lakes is above 32 degrees Fahrenheit, while in comparison, the temperatures over the land will be considerably cooler. Thanks to this phenomenon, evaporation occurs at a much higher rate over the water. This evaporated water rises upward, and when it reaches a certain height in the air, will usually condense out as a cloud. You may have noticed here in December that it is almost permanently cloudy. In Michigan, thanks to the lake effect, December rates for insolation are as much as 50% of what is received in areas upwind of the lakes. But these clouds don't just make everything dreary, they also keep in what little warmth we have. Without clouds, the warmth would escape back out into space, and it is a primary reason why temperatures are so much warmer in Michigan as compared to an area in the same latitude over in Minnesota. But the effect on clouds is a double-edged sword. During spring, when the temperature in the lakes are much colder than in the air, the lakes have the opposite effect, where cloud formation is suppressed, leading to much sunnier and less rainy conditions over Michigan. Lastly, the snow. The lake effect snow machine requires 5 main things. 1. You need a difference in temperature between the lake surface and the air 1 kilometer up in the sky greater than 13 degrees Celsius. 2. You need an inversion layer where temperatures are colder at the surface as compared to the air above it. 3. You need a wind fetch of greater than 80 kilometers over open water. 4. You need wind speeds of at least 11 miles per hour. And 5. You need rising surface pressure. If these conditions are met, and they frequently are here in Michigan in the winter, then you'll have snow. Lake effect snow usually comes in the form of belts or long fingers. These areas get light snow continuously for hours at a time, which, depending on winds and the amount of available moisture, can go from light flurries over a large area to a full-on blizzard in localized areas. But if the lakes freeze over, like they did in 2014, then you can throw all this out the window. With ice covering the lakes, the region becomes just like any other mid-continental region, and the lake effect shuts down.